Earendel, the oldest star ever discovered, is buried someplace in this James Webb image. And I bet you can't see it. But don't worry, we'll be there shortly. However, first let's look at how lenses function. These astonishing technologies can alter light, bending its beams in seemingly magical ways that are actually based on simple physics. You may be curious about the relationship between a lens and the universe's earliest star. The link is more significant than you might think. Allow me to walk you through this video in which all of your questions will be answered. Furthermore, I will discuss how the finding of Earendel has the potential to unravel the cryptic secrets of the Big Bang. A perplexing enigma. So where is Earendel in the picture? Is it going to be one of those large lights in the center? No, these are elliptical galaxies. Unlike spirals with arms or irregulars with chaotic forms, elliptical galaxies appear symmetrical and lack distinguishing traits. They are largely formed of older stars and have less interstellar gas and dust. They come in a variety of sizes, from tiny to supergiant, and are frequently seen at the center of galaxy clusters. Their development is linked to events like as galaxy mergers, which combine smaller galaxies to form a larger elliptically shaped galaxy. Is it going to be the six-spiked star in the center? No, that is a star from our galaxy. These spikes are optical artifacts called diffraction spikes, which are created by the telescope's design. If astronomers see a star with 6 spikes in Webb's photos, it is a visual clue indicating the star is part of our Milky Way galaxy. This anomaly is caused by the telescope's optics and does not appear in stars from other galaxies caught in the photos. It's an interesting trait that helps scientists distinguish between stars in our galaxy and those in distant galaxies while studying James Webb Space Telescope data. So where is it? Spotting Earendel. It is here. Ladies and gentlemen, this is the oldest star in the cosmos. Do you feel the thrill and adrenaline rushing through your veins and along your spine? If not, take a moment to consider this beauty. As previously proven, each object in this image, with the exception of the hexagonally spiked stars, represents a distinct galaxy. This image features several galaxies, including Earendel. It, like all other stars, is part of a galaxy called the Sunrise Arc Galaxy. As you can see, this galaxy stands out among its peers, hinting to some fascinating events. I'll get to that shortly, but first, a question for you. Have you ever considered how difficult it would be to observe a single star in a galaxy filled with millions, if not billions, of stars? To put things in perspective, consider Andromeda, one of the Milky Way's closest neighbors. It has been extensively studied and is destined to collide with our galaxy, but do not fear. Such an event will occur well beyond our lifespan. Andromeda image. Returning to our subject, when we look at galaxies like Andromeda with devices like the Hubble Space Telescope, we mostly find brighter than average stars. Bright stars image, however, these are only a few of the galaxy's innumerable stars. Skeptical? Allow me to illustrate. I'll zoom in on the finest view of the Andromeda galaxy ever taken by Hubble, highlighting its astounding immensity. The further you zoom, the more stars appear, an infinite sea of light and stars. Identifying one star from another becomes a difficult process. However, when we look at galaxies far away, the resolution of our telescopes prohibits us from appreciating them in great detail. We see merely the galaxy's shape and possibly some broad features. This is true for most of the galaxies in the James Webb picture. James Webb image, as a result, locating a single star within a galaxy, specifically Earendel in the Sunrise Arc Galaxy, is a difficult task. In reality, it would be impossible without a spectacular natural phenomenon known as gravitational lensing. Gravitational lensing. Imagine the universe as a large landscape with galaxies as gigantic mountains. Light is a voyager exploring the universe. Light moves in a straight line through space, much as a climber climbing a hill. However, as our light traveler approaches a giant galaxy, the galaxy's gravitational field warps the space around it, forming a gravitational well or deep valley in our landscape example. As a result, the straight route of the light is warped by this gravitational well, just like a hiker's path bends as they descend into the valley. Consider a distant object, such as a background galaxy or a star, that lies behind our huge galaxy. The light from this background object must transit through the gravitational well generated by the foreground galaxy before reaching our observer, like a hiker on the opposite side of the valley. The gravitational force bends light, causing it to travel in a curved direction. From the observer's perspective, the bending of light produces a distorted and magnified image of the background object. It's as if the foreground galaxy serves as a huge lens, focusing and magnifying light from the distant object. This phenomena enables astronomers to investigate objects that would otherwise be too weak or distant to see directly. It functions as a natural telescope, offering a unique view of the universe's more remote and hidden regions. Gravitational lensing is thus responsible for the unique shape of the Sunrise Arc galaxy, which includes Earendel, and it is also the reason we can see Earendel. This star is 12.9 billion light-years away, making it the furthest star ever observed. Despite the enormous distance traversed, the light from Earendel has finally reached the James Webb Space Telescope due to a gravitational lens that magnified its luminance more than 40,000 times. This amplification is made possible by the existence of the massive galaxy cluster, WHL 0137-08, between the Sunrise Arc galaxy and ourselves. Earendel's light originated inside the universe's first billion years, making it a stunning discovery from a time when the world was substantially different from what we know now. It is probable that Earendel is among the earliest generation of stars ever born, with its birth occurring less than a month after the Big Bang, if we consider the time from the Big Bang to today to be a whole year. Isn't that incredible? The term Earendel comes from the ancient English language and means morning star or rising light. Furthermore, Earendel is not only the name of a semi-elf character in J.R.R. Tolkien's famed novel The Silmarillion, but also of a person who traveled across the heavens carrying a shining stone that blazed brightly like a star. Surprisingly, Michelle Thaler, an astronomer at NASA, stated that the allusion to Tolkien's writings was deliberate in this discovery. Webb's findings. Although Hubble discovered Earendel, the James Webb Space Telescope has afforded us with incredible detail. This is exactly how it transpired. Earendel's existence was disclosed to the globe by Hubble in March 2022. Only a few months later, in July, Webb delivered its first photographs and announced its readiness to begin scientific activities. Earendel was one of its initial observations, and the results are now available to the public. Webb's examination of Earendel involved more than just taking pictures with a camera. It also used a spectrometer. This apparatus divides the star's light into several components, allowing us to acquire a better knowledge of its properties. Spectroscopy classifies stars based on the appearance of their spectra, which are designated by letters ranging from O to M in consecutive sequence. Although it may appear arbitrary, this classification system has a rich historical basis that I hope to explore further in the future. Webb's measurements show that Earendel belongs to the main sequence and is categorized as a B-type star. Main sequence refers to stars in their prime, neither too young nor at the end of their lives. B-type stars are massive and extremely hot, with some reaching twice the size of our Sun and emitting temperatures in the thousands of degrees. To the naked eye, they usually appear blue. B-type stars in the constellation Orion include Bellatrix, which is located on Orion's shoulder, and Rigel, which is stationed at his knee during the winter. Stars like Earendel are frequently part of binary systems, accompanied by a smaller and dimmer counterpart. Detecting such a companion at Earendel's distance presents enormous hurdles. Even in our own Milky Way, finding companion stars can be difficult. However, the lack of visibility does not rule out the possibility of a companion. Intelligent inference is required. Webb's spectroscopic investigation of Earendel's light gives tiny hints about not only Earendel's brilliance, but also a cooler, dimmer, and redder partner. What makes this discovery so intriguing is that the wavelengths of this companion's light are outside Hubble's observational range. Hubble was not designed to detect the companion. Webb, on the other hand, provides the essential capabilities, permitting the discovery of hidden phenomena when these two telescopes work together. This aspect of their relationship is very compelling. The importance of Earendel. The discovery of Earendel gives scientists with a unique opportunity to investigate the properties of the early universe. Our understanding of stellar physics is based on the premise that all stars in the universe have attributes similar to those observed near our Milky Way. The first stars to form in the universe, known as population 3 stars, are thought to be made entirely of hydrogen and helium. However, they have never been directly detected. The capacity to study a star from such a long distance allows us to test the validity of this notion. This scrutiny is critical because it has the potential to undermine our current understanding of the universe. Will James Webb confirm that this is actually a population 3 star? We'll definitely keep you updated. Alright everyone, this video ends here. Thanks for watching. What are your thoughts about Earendel? Please let us know in the comments below, and remember to like, share, and subscribe.